Welcome to section 9.3. Today we're talking about trigonometric ratios. That's a big word. That's a new word for probably all of us. Maybe some of you have seen these before. Maybe you have an inkling about what we're talking about, but today might be an exciting brand new day for us. So that's kind of cool. So far in this section, we've talked about right triangles. Right, section 9.1 was all about right triangles. Then we talked about our special ones, 45, 45, 90. We talked about 30, 60, 90. We were working with missing sides, figuring out those side relationships with our special right triangles. We're still going to be talking about right triangles, but now we're going to learn about these new things called trig ratios. So this is just a light little intro into trig. It might be very like, what, new, wow, huh, today. That's totally cool. That's totally fine. Give yourself grace as you're learning something new. So we're going to learn about these things called the sine, cosine, and tangent ratios. Like I said, this is just going to be an intro. You're going to hit these topics a lot harder in different classes like math analysis, pre-calc. If any of you take calculus, Calc 2, you'll deal with those a lot. These will show up on the SAT and the ACT. These ratios help us figure out missing side lengths and angle measurements in specifically right triangles. So first, what is trigonometry? So it's derived from the ancient Greek, as a lot of our lovely mathy words are. So it's a Greek term, and it basically means three-angle measurement. Well, three-angle, you could also think about that as triangle measurement. So trigonometry is all about triangle measurement. It's very closely linked with triangles, and especially right triangles. So we haven't really talked about similar figures yet. We're going to the next couple of chapters. We've talked about congruent figures, but similar figures are if you have two figures that look pretty similar, pretty alike. They all would have equal angle measures, but different side lengths. So for instance, these two right triangles, let's say that I knew that all of their angles or corresponding angles were congruent, but their side lengths were different. This would be an example of similar figures. So these trig ratios kind of come from similar figures. For similar figures, we know we have equal angle measures. Equal angle measures, and the ratios of corresponding sides, the ratios are equivalent. So the ratio of the hypotenuse on this one to the hypotenuse on this one, it's going to be the same as the ratio of the shortest leg on this one to the shortest leg on this one. Okay, so what trig ratios are is basically this. Just the ratios between sides for similar figures. We know anytime you're dealing with a triangle that has these particular angles, these ratios are going to hold true. And we have special names for some of these ratios, which we'll get into on the next slide. So there's a lot of info on this slide, and I'll zoom out a second so you can read that fully. So trigonometric ratios, remember, we're dealing with a right triangle. We're going to focus right now on just one angle, an angle A. You could find the ratio of all three different pairs of your sides here based on this particular angle. So you're going to have the sine, the cosine, and the tangent of this angle. So I'm going to focus right now on angle A right here. To find the sine of angle A, it's just the ratio of the side opposite angle A, so little lowercase a, that's your opposite side. It's across from that angle. And it would be over your hypotenuse, which we're calling C. So sine of angle A would be opposite over hypotenuse. The cosine of angle A would be adjacent. Remember, adjacent just means right next to, so in that case, it would just be B over the hypotenuse. So the cosine of angle A would be the ratio of adjacent over hypotenuse. And then the tangent would be opposite over adjacent. So your opposite was that A, adjacent was that side right next to B. So this is new. This is different than a lot of stuff we've done. Trig ratios have special names So if you're dealing with the ratio of, I'm focusing on one angle and I want the ratio of the opposite side over the hypotenuse, that's called the sine of that angle. On your calculator, they just use the first 3 letters of each of these fancy names. So maybe you've seen sine, cosine, and tangent like that on your calculator. You'll have sine of some kind of angle and it'll spit out this ratio A over C or some kind of number representing that ratio. So a nicer way to think about sine, cosine, and tangent, because this is a lot of information here. So the way I want you to remember this, it's cool if you're writing this down. That's awesome. That's going to give you depth of knowledge. But the easiest way to remember this is using SOHCAHTOA. Some people write it out like this, SOHCAHTOA. I like to write it out like this. I think it's even easier. SOHCAHTOA. So what SOHCAHTOA is, it's a nice little shortcut for us to remember sine, cosine, and tangent, and what do we mean by sine, cosine, and tangent. So sine, S, is the ratio of the opposite side over the hypotenuse, so O over H. Cosine is the ratio of your adjacent side over your hypotenuse. And tan over here, let me include sine, tan over here is the opposite side over the adjacent side. So we're using letters, it's kind of an acronym here, SOHCAHTOA, to help us remember what sine, cosine, and tangent actually represent. Okay, this is a lot. This is new. Pause, write down whatever you need to. Otherwise, we're going to move on to an example and see how we can actually use these to help us with a real triangle. So example 1, what are the sine, cosine, and tangent ratios for angle T? So they're asking us to focus on this angle over here. Sine of T, well, remember SOHCAHTOA. You can either write it out like this, SOHCAHTOA, or you can write it out like this, whichever way works better for your brain. Sine would be opposite over hypotenuse. The opposite side from angle T would be 8. The hypotenuse is across from that right angle, so 17. So the sine of angle T, that ratio would be 8 over 17. If you plugged it into your calculator, you would get 0.4706, something like that, okay? What about the cosine? What's that ratio? Well, going back to SOHCAHTOA, cosine is adjacent over hypotenuse. Our adjacent side would be right next door, so that's 15. Our hypotenuse is 17. If you plug that ratio into your calculator, you'll get 0.8824. And then tangent of T, going back to SOHCAHTOA, tangent would be opposite over adjacent. Our opposite side we already said was 8. Our adjacent side we said was 15. So depending on how they're asking you for the answer, right, sometimes you'll just leave it in that fraction form in that ratio. Here I'm just showing you both. So if you plug that into your calculator, it'd give you 0.5333. And anytime you have a triangle with sides that are multiples of these numbers, you'll end up getting these same kind of simplified versions of this. Okay, so this is how you would find your different ratios for a particular angle. Let's move on to another example. So here I'm dealing with a familiar right triangle, the 45, 45, 90. They're asking for the sine, cosine, and tangent of 45 degrees. So you could use either one of these 45-degree angles. I'll just kind of think about this one up here. So sine of 45, and now I'm going to actually go ahead and plug this in, right? It's sine of an angle. Here they're asking me for this specific 45-degree angle. Remember SOHCAHTOA. Sine is opposite. That would be 1 over hypotenuse. That would be radical 2. Got to rationalize that. So multiply by rad 2 over rad 2. You'll get radical 2 over 2. That's sine of 45. Cosine of 45 would be my adjacent side, which also happens to be 1 over rad 2. Okay, same exact thing here. Got to rationalize. We'll end up with the same answer, rad 2 over 2. So cosine and sine of 45 are going to give you the same thing. And then tangent of 45, That's your opposite over your adjacent. 1 over 1 is just going to give us 1. So these are your 3 answers for sine, cosine, and tangent. And if you plug these into a calculator, right, try this out. Rad 2 over 2 is going to be 0.7071. If you plug into your calculator right now, cosine 45, using that cos button, you'll get 0.7071. Okay, so that is what your calculator is doing. They're figuring out what's the ratio of these two sides. They're kind of envisioning a right triangle, and they're looking at a 45-degree angle in that right triangle, and your calculator is going through this process to spit out this number over here. All right, how could I apply this in the real world? Maybe I'm trying to find the distance across a lake, so a surveyor is going to take measurements shown in the figure. So from this point A to this point here, C is 630 yards. And they also know that B is directly across the lake from C, and they know this angle A is 40 degrees. Use these measurements to determine how far it is across the lake. So if I'm trying to focus on angle A, and we know the measure of angle A is 40 degrees, what two sides of my triangle am I dealing with? Opposite, adjacent, or hypotenuse? Well, my opposite side is represented by A. That's the thing I'm trying to figure out. I don't know my hypotenuse, but my adjacent side we know is 630 yards. So right now I have info about an angle, and I have info about opposite and adjacent sides. So let's use a trig ratio to help us solve for that missing A value. Which trig ratio deals with opposite and adjacent? Think SO is opposite over hypotenuse, cosine is adjacent over hypotenuse, TOA, I'll write it out here again, so TOA, tan is opposite over adjacent. So I can write this trig ratio, tan of 40 degrees equals opposite A over adjacent 630. And we can actually solve this equation. So you're going to have to use your calculator for this one. I want to get A by itself, so I'm going to multiply both sides by 630. And we're going to get A equals 630 times tan 40 degrees. You're going to have to plug this in. We can double check this next week on Monday. Make sure your calculators are all in the right setting. They should all be, but your calculator could either be in a degree setting or this thing called radians. We want to make sure it's in the degree setting. So when you plug this into your calculator, you're going to hopefully get for tan 40.8391. Just double check that you're getting that. If you're not, just make a note. We need to look at your calculator next Monday and make sure that it's put into degree format. If you're getting that, then go ahead and multiply 630 times tan 40. We should get that A is about 529 yards. And that would be your answer for this one, okay? So just double check that your calculator is giving you that, and then like I said, just make a note somewhere, or you can Google and figure out how to switch the mode on your calculator from radians to degrees. And then you'll be able to just type this whole entire thing into your calculator, 630 times tan, using that special tan button, 40, and you get 529. So if we need to do some work with that next week, totally fine. We can definitely spend some time on that. Do your best while I'm gone this week. All right, we have 2 more examples for you. One more example. Another thing we can use trig for is finding missing angles. So these are, think of them as like a whole different type of function, basically. So we have sine, cosine, and tangent ratios. So SOHCAHTOA. If I want to find that angle, so like in one of our problems, like we had sine 45 degrees, right? Equals opposite over hypotenuse. Well, let's say I know what both of these are, and I'm trying to figure out what the angle is. I could have sine of, I don't know, x, representing some angle, equals, 1 over 2, something like that. What we can do is we can use these inverse functions to figure out what the measure of our angle is. I'm going to introduce this to you all today, and then this is something that we definitely will go over next week and make sure we know how to use our calculators to find these. So if you were going to use an inverse function, it would look like this. If you know this is true, to find x, you would plug into your calculator this inverse sine of 1/2, and it'll spit out some degree. And that's going to represent your angle. Okay, so this is a brand new function. Sine, remember, is meaning that ratio between two sides. If you want to find a missing angle, you would use this button on your calculator, sine with the little -1. It means inverse sine. That function, you would plug your ratio into that function. It'll spit out what that missing angle is, okay? So we're going to do one example, and then, like I said, we can spend some time on this next Monday. We will sort out anything we need to sort out. So for example, maybe you're trying to find a missing angle, like angle X. You would first need to think, okay, for this particular angle, what two sides do I know? Well, 6 would be your opposite side. 10 would be your hypotenuse. Okay, so which trig ratio deals with opposite and hypotenuse? Think SOHCAHTOA. Sine deals with that. So I could say sine of x equals opposite over hypotenuse, in our case 6/10. So what we want to do then to find the measure of angle x is we would want to figure out what is the inverse sine of 6/10. And folks, again, this is not math that you can even do in your head. You would need to use a calculator. So you would have to find your inverse sine button, plug that in, do 6 divided by 10, this ratio over here, hit enter, and you'll get about 36.9 or 37 degrees. That would be our answer for this one. So just try this out in your calculator. For many of you, your calculators will be in the right setting. Try to find your inverse sine button. That might be half the battle. So if you're like, what the heck is happening right now, Miss Curlin, where, I don't know how to use my calculator, guess what? I'm going to ask you to Google it because you can figure this out. It just may take us a second to find the inverse sine button. That's totally fine. You can do it though. I believe that you definitely can. So try it out. We'll sort everything out on Monday if we need to. So I'm going to do part B over here. I'm trying to find my missing angle X. I know that I have these two sides, 15 and 20. Which sides are they for this angle? Well, 15 would be my adjacent side. 20 would be my hypotenuse. Which trig ratio deals with adjacent on hypotenuse? It's going to be cosine. So I could say cosine x equals adjacent, which is 15, over my hypotenuse, which is 20. To try to find the measure of angle x, then I would need to plug inverse cosine of 15 divided by 20 into my calculator. When you plug that into your calculator, you're going to get something about 41 degrees. Okay, so try it. Try it out. See how far we can get with this. If you can't figure out where those buttons on your calculator are, Google it, type in the type of calculator you have, and then where is inverse cosine, and try to find it. Do your very best. You all are pros with technology anyway. So I fully trust you can figure this out. And then just write down your questions. Okay. So, whatever you've had questions about from this entire chapter, 9.1, 9.2, 9.3, write down these questions. That's what we're going to spend Monday on. Monday is like our triage day to kind of go over everything, see what we need to catch up on, see what I need to explain differently or again, and we will go from there. But congrats, this is the last of the sub-plan videos for you. You will have a little bit of homework to do on this section just to give you some practice today or over the weekend whenever you decide to do it. Good luck. Congrats for making it through these videos. See you next week.